Hi guys, welcome back to the Art of Server. So this video is part 2 of a series of videos where I'm going to be testing out the power consumption of LSI HBA SAS controllers. And in this part 2, I'm going to be testing out 16-lane internal 16-lane HBAs. And so the first one we're looking at here is the LSI 9201-16i. And I'm going to be also testing this 9300-16i, as well as a 9305-16i and a 9400-16i, and underneath that is a 9500-16i. So if you haven't seen the other videos in this series, I recommend you go back and check those out. In the first part, I tested the power consumption of all the 8 internal SAS lane HBAs that I have in my collection here. And there's also a video that goes over this setup to explain to you how the setup works and all that. But to quickly recap how we're going to measure the power consumption of this system, I'm using this interposer board right here that is from Elmore Labs. And this basically cuts off power from the PCIe slot from the motherboard and supplies power through this cable, which is metered through this device, which is the Elmore Labs PMD2. And so I'll have a camera set recording this so you can see what the power consumption is as I'm running the tests and load tests as well. You'll see that I have 2 cables connected right now to the 9201-16i, and those are connected to these 8 SSDs, and these are SAS-3 SSDs that are capable about 150,000 IOPS each. And so roughly I can do a little bit more than I think in the last test we were able to hit about 1.5 million IOPS in total. And so we're going to be using this to load test the HBAs to see how that affects power consumption. All right, so let's go ahead and get started and get on with the testing. Everything's booted up right now. Let me just show you first that the controller is visible. And so you'll see here we have the SAS2116 chipset, which is associated with the 9201-16i. And there's the firmware and all that jazz. So the controller is there. If I run LSCSI, you'll see that we have the same 8 SSDs that were used in the previous part of this series. And right now, if you're looking at the PMD2, it's reading 13, hovering between 12 and 13 watts for this 9201-16i at idle. And so now we're going to run a 4K random read test with FIO. And so I showed the same thing in the last video, but just for completeness, I'll show you guys. This is the file script I'm going to be using. So if you want to see the settings, you can pause the video here and take a look at the settings. And at the bottom here, you'll see that I'm set up to run this test on these 8 SSDs. So drive SDB through SDI. All right, so let's go ahead and get set up for that. All right, so we are baseline right now is hovering between 12 and 13 watts. And let's go ahead and run the test now. All right, so the power consumption jumped up to between 14 and 15 watts. So it did jump up a little bit. And we're seeing about 350-ish IOPS. Bandwidth utilized is about 1.3 gigabytes or so there. All right, so the test completed, and the power consumption is now down back to between 12 and 13 watts. So it was hovering between 14 and 15. So basically, I think it gained about 2 watts under load. And the final results here, if you look under IOPS, we had an average of about 349,000 IOPS, and the average bandwidth was about let's say 1.4 gigabytes per second. All right, so I'll go ahead and shut down and we'll move on to the next card. All right, next up is this card right here, which is the 9300-69, and this is a dual LSI SAS 3008 chip with a PLX PCIe switch in between them. And so this PCI connector actually connects to a PCI switch that then connects to the two SAS 3008 chips on this board. So this is one of the hottest running cards, so it'd be interesting to see how much power this is going to take up. For the SSDs, since I only have 8 SSDs, I'm going to connect one set of 4 SSDs to each SAS 3008 chipset, and that way we can kind of distribute the load across both chips and basically utilize the PCI switch in both directions. The machine's booted up right now, and if I run SAS3 Flash, we'll see the controllers. So here's one of the SAS 3008 chips, and this is part of the 9300-69. So if I run -C1, you'll get to see the second chip, identical version of firmware and all that. And right now, as a baseline, you can see that we're hovering around 23 to 24 watts at idle. So this is definitely one of the more power hungry cards. Now this card, if you need, well, it's going to need more than 25 watts possibly. My guess under load it's going to need more than 25 watts. And so if your PCI slot does not or is not able to supply the more than 25 watts, you do need to plug in a 6-pin PCIe power to the card directly. So I don't think we're gonna have that problem with this this setup right now. So I only have it. I'm only supplying power through the that Elmore Labs interposer. All right. So once again, show you that the 8 SSDs are here. Okay, I don't have 8 SSDs. I have 7 SSDs. Let me check on something. It looks like I have a missing PCI lane. Let me see if I can remedy this situation. Okay, that was a wrong cable. That's one seemed to be okay. Plug that back in. Okay, so let me unplug this other cable. Alright, so that's the one that was missing a drive. Let's see if I'll get it back. Not having much luck. Let me check the connections on the SSD side. Okay. That wasn't it, so maybe it's this one. Nope. Oh, okay. There we go. One of the power plugs popped off the cable. So these SAS SFF 8482 connectors need to be supplied power, and the SATA plug popped off there. So all right, looks like we have all drives now. Let's do this again. Yeah, so STB through STI. All right, so we can go ahead and prepare the the 4K random read IOPS load test. All right, so again, as a baseline, we are hovering between 23 to 24 watts. And now we're going to put it under load. Okay, so we are pushing about 1.4 million IOPS and 5.8 gigabytes a second or so. And the power is up to 25 watts. Huh. Okay, so we are done here, and the average IOPS was about 1.49 million IOPS, so that's basically about 1.5 million IOPS, and I think that's about the limit that we saw last time on the higher end. So that might just be a limitation of these SSDs. I don't have enough SSDs basically to push it any higher. And the bandwidth, we actually got about 6 gigabytes a second through that card. And so the power is now down to about 24 watts, between 23 and 24. It was a solid 25 watts under load. You know, I'm kind of wondering if it would suck more power if I plugged in the 6-pin to the card. So, you know what, let me power down and try that out. Okay, so I don't know if you can see it here, but there's another PCIe power cable I just attached, and that's plugged into the 9300-16i card right now. And so at idle we are seeing the same 23 to 24 watts. I'm just a little curious whether it would draw more power under load, provided that extra power there. So here I am about to run the FIO test, so keep an eye on that power. Let's go ahead and run the test. Okay, so we're hitting about 1.4, almost 1.5 million IOPS, and power is still around 25 watts. So okay, I guess it didn't really matter. All right, so the test is over. Power went down from 25 watts down to now 23 to 24. And we basically got roughly the same numbers, I think. Yeah, about 1.49 million IOPS and about 6 gigabytes per second. Okay, well, that's it for that. Let me go ahead and shut this down, and we'll move on to the next card. All right, so the next card here is the 9305-16i. This is based on a slightly newer revision of the SAS 3008 chipset. It's known as the SAS 3224, and it's actually a 24-lane chipset, but 8 of them are disabled here because you can see that the ports are missing there. So it's the same, basically it's the same chipset as the 9305-24i, except it's got the 8 ports missing. This is a single chipset design, so unlike the previous one, it doesn't really matter, I think, where I plug these cables into, but I'll kind of spread them out anyway. All right, let's boot up. Okay, so system is booted up now with the 9305-16i card. One thing that I thought was kind of strange that you guys might see in the post footage is that the Avago Technologies banner didn't show up, which is like the LSI ROM loading. And so for whatever reason it didn't do that, and I thought maybe this might be one of those problematic cards that won't work in this interposer, but it seems to be okay. So for example, you can see with LSPCI that the card is right here, it's visible, and again it's based on the SAS-23 or 3224 chipset, and if you look at the link speed, it is in fact linking at PCIe 3.0 by 8, so it seems to be okay. And if I run SAS-3 flash, you'll see that the firmware is responding and showing the SAS address, firmware version, and all that stuff. So it seems to be operating okay. I'm not really sure why it didn't load the LSI ROM during post, but anyway, so if you're looking at the power meter here, or the PMD2, it's showing that this card is drawing about 13 watts right now, which is a lot better than the last card, the 9300-16i. So for those of you who are wondering, I typically recommend this card over the 9300-16i just because that one is quite a power hog. Now the other one is based on two SAS 3008 chipsets. Each of them can handle a little bit more than 1 million IOPS. So theoretically, that card can handle about 2 million IOPS if you fully load it with enough SSDs to, push that limit. My SSDs, I only have 8 SSDs here, so unfortunately I cannot push the limit of both of those SAS 3008s in the last card. I don't know what the IOPS limit is of this card. I'll look it up later when we look at the summary results, but we'll see. Okay, so let's go ahead and run a test. But right now the baseline is about 13 watts at idle. So let's go ahead and run the load test. Okay, so it's doing about 1.38 million IOPS right now, and the power consumption went to about 14 watts. So not much of a change, just about like 1 watt or something like that. So now it's about 1.4 million IOPS. So this might again be a limitation of the SSDs that I have, rather than the limitation of the controller. But we'll compare these numbers to what the Broadcom literature says. Okay, so the test is done and the power has gone back down to 13 watts. Okay, so let's see here. We are seeing IOPS of about 1.433 million IOPS and about 5.8 gigabytes per second. Okay, so that's it for that test. Let me go ahead and shut this down and we'll move on to the next one. Okay, so this is the next card, which is the 9400-16i, and this is based on the LSI SAS-3416 chipset, and this is the one that first introduced an ARM-based chipset instead of PowerPC. Also, in the first part of the series with the 9400-8i, which is the 8-port equivalent card, I had some problems running that card in this interposer board. I had to slow it down to PCIe 2.0 for it to be recognized. I don't know if I'm going to have that problem again, but I'm going to try it out, and if I do, I'll lower the speed back down to PCIe 2.0, and I'll let you guys know about that, of course, if I have to do that. But hopefully, I don't know. I guess I can be hopeful, but I kind of get a feeling I'll probably have to run this in PCIe 2.0. This is also a single chip design, so I don't think it really matters where I plug the cables into, but I'll spread them out like before. Alright, let's go ahead and boot this up and see what happens. Okay, so you guys might have saw the post footage and the card showed up. I didn't have to change any PCIe settings, so kind of curious to see what we got here. So yep, there's a 9400-16i and link status, yep, PCIe 3.0 by 8. So that's really interesting. I was really thinking that I'd have the same problem as I did with the 9400-8i card as in the first part, you know, what happened in the first part of the series. But for whatever reason, this 9400-16i has no problems operating in that Elmore Labs PCIe riser. Okay, so let me just show you guys the status of the controller. Okay, scroll up a little bit here. So there's the 9400-16i, and here's the firmware version and all that stuff. And of course down here we see a list of the SSDs that are attached, and I do indeed have 8 of them. And if you look at the PMD2, it says that the 9400 right now is drawing about 8 watts at idle. So well, hovered a little bit into the 9 there for a little bit, but it's mostly hanging around 8 watts right now. Okay, so let's go ahead and run that load test on it and see what happens. Alright, so it bumped up to about 9 watts. From 8 to 9 watts. We're doing about 1.4 million IOPS. So that definitely is more energy efficient than the last card. And the power consumption really doesn't change that much. So this is pretty much what we saw in the first part too, with the 8-lane controllers as well, where under load it really only consumed like 1 or maybe 2 extra watts. Alright, so the load test finished and the power consumption went back down to 8 watts. Okay, so what did we get here? We got 1.444 million IOPS and almost 6 gigabytes per second there. Alright, cool. Let's move on to the last one, which is the 9500-16i. Alright, so for the final test, we have a 9500-16i, and this is going to require a different connector, so I'm going to have to swap out the cables. So this is capable of 3 million IOPS, so definitely we won't be able to hit that limit with the SSDs that I have, but we'll see what happens. And with the 8-lane version of this card, we saw some really great power consumption improvements. Basically, it was very, very low power. It basically consumed the same amount of power as the first generation card. So it'll be interesting to see how this compares, for example, with the 9201-16i. Okay, so we're booted up with the 9500-16i right now, and as a baseline you can see that the power consumption is sitting about 6 watts. And let me just kind of show you the controller status. Okay, so there is the 9500-16i. And here's the firmware version, and as we saw earlier, there are 8 SSDs attached that are recognized. And if I run LSCSI, here are the 8 SSDs. Alright, so let's go ahead and run the load test to see how that affects this card. Now right now it is sitting at about 6 watts. So here we go with the test. All right, so it's pushing up towards 8 watts, kind of hovering between 7 and 8, so it's probably in the high 7s, sitting around 7 to 8 watts. We're seeing about 1.4 million IOPS, which I think, again, this is probably the limitation of the 8 SSDs that I have, not necessarily a limitation of the card. But under this load, it's basically consuming about 2 watts more. So that's about a 33% change in power consumption from 6 watts to about 8 watts. All right, so the test is done, and we saw an average of 1.433 million IOPS. And again, I don't think that's a limitation of the controller, but rather the SSDs that I'm using. We saw the bandwidth consume about 5.8 gigabytes per second or so. All right, so that's the end of this test. Let me put all the results we got into a table, and then we'll discuss that and finish up this video. I've put together this table of all the results we just collected from all the testing in the prior part of this video. And so let's go ahead and just go over this. So starting from the second generation card, which is the 2116, basically the chipset for the 9201 16i, there is no first generation card that has 16 lanes. So the first card we're testing here is from the second generation. And we got about almost 350,000 IOPS there. The specifications from Broadcom's documentation was about somewhere greater than 430,000 IOPS. So this is kind of interesting because in the last video when we tested the SAS 2008 card, the 9211 8i, we had a situation where we had the IOPS somewhere in the 400,000s, which was higher than the specification. Bandwidth came in at about 1.4 gigabytes per second or so. The power specification from Broadcom's documentation says that the nominal power consumption is about 16 watts, and I think this is pretty close to what we were seeing. We saw 13 watts at idle, and under load about 15 watts. So this is, I think, fairly close. This is a PCIe 2.0 card that supports the first generation that supports SAS-2 6 gigabits per second. So anyway, this used to be one of the more favored 16-port cards, but I think there are obviously better options today, and also this card is incredibly hard to find right now. And whenever it is available, it's, I would say, a bit overpriced. So, so anyway, I think there are better options that are more affordable, and we're going to talk about some of those next here. So, all right, so the next one is from the SAS 3008 generation. So this is 4th generation, because the 3rd generation, which would be something like the 2308 chipset, did not have an internal 16-port card. There was an external one, which we will be testing in another video later on when I test the power consumption of external port cards, but there was no internal port version, so we had to skip to the next generation, which is the SAS 3008. And the first iteration of a 16-port card they as in Broadcom or LSI made was the 9300-16i, and this was basically a dual chip design. There was basically 2 SAS 3008 chips glued together with PLX switch. This is the first generation support SAS-3 12 gigabits per second, and this is still a PCIe 3.0 card with 8 PCIe lanes. So in this case, the specification for IOPS basically is kind of based on the single SAS 3008 chip, which was rated at more than 1 million IOPS. So in this case, it would be roughly somewhere 2 million and higher. And we got about 1.5-ish, close to 1.5 million IOPS. And I think this is really consistent with all the other testing we've done, that this is really a limitation of the SSDs. I just don't have enough SSDs. This 16-port card, obviously, I could connect more SSDs, and we could probably exceed the 2 million IOP limit here if I had more of those same SSDs that I'm using, but unfortunately I don't. Bandwidth, we got about a little bit over 6 gigabytes per second. And the nominal power rating for this card is 27 watts, and we saw an idle power of about 24 watts, and under load it was about 25 watts. And I thought it was kind of interesting that it was hovering around 25 watts under load, and I briefly thought that maybe it had something to do with the PCI slot, because it is a by 8 PCI slot, and I don't know if maybe it could not negotiate higher power usage or not, and therefore ended up just kind of limiting itself to 25 watts. Maybe, I'm not exactly sure. But that's why I added the 6-pin PCIe power to the card directly, just to see how it would behave, and it turned out to be the same. So that's what it is. I'm not really sure if it can use more power under a heavier load, but we got a under load situation of 25 watts, which is still coming in a little bit below the nominal power rating from the documentation. All right, so after that generation, there was a very similar kind of updated generation of the SAS 3008. And so I usually call this like the 5th generation. And basically, they just took the same technology, I think, and added more ports. So this is the SAS 3224 used in a 16-lane card. So they basically just take the same chips and disabled 8 of the lanes. And this is a PCIe 3.0 SAS-3 12 gigabits per second card. It is a single chip design that has more lanes. And this is rated at above 1.5 million IOPS, and we got 1.43, so I think that's close enough. And we got for bandwidth about 5.8 gigabytes per second. And the typical power consumption as provided by Broadcom's documentation was 6.2 or 16.2 watts. We saw an idle power of 13 watts and under load 14 watts. So we're coming in a little bit below what Broadcom's documentation specifies. All right, so moving on to the next generation. This is the first generation to move to the ARM architecture and in the introduction of tri-mode. So this is the SAS 3416. It is a PCIe 3.0 card, supports SAS 3 12 gigabits, and as I mentioned, has the tri-mode feature and is based on the ARM architecture. So this is the transition to the ARM architecture, and I think primarily to reduce the power consumption rise that we have been seeing in the previous generations. And the IOPS rating for this card in the documentation is a little bit vague. They basically kind of say that it's a little bit better than the previous generation without really specifying exact numbers. And so, and I mentioned this also in the last video as well. But so I've written down, if the last generation was 1.5 million IOPS, then I've written down 1.5 million plus some question mark. Right. So, and we got 1.44 million. Again, I think all these 1.4, almost 1.5 million IOPS, this is a limitation of the SSDs that I currently have for this testing. But this is seems kind of close enough. Perhaps it could go a little bit higher if the SSDs were more performant. Bandwidth-wise, we got almost 6 gigabytes per second. And the typical power consumption as specified by Broadcom's documentation says that the typical power consumption is 11.95 watts. We saw in our test 8 watts at idle and under load 9 watts. So this is coming in somewhat lower than the specification, which is the same thing we saw also in the last video with the 9400-8i. I'm not sure how or why Broadcom's documentation seems to specify a higher power rating for this generation, but has so far in the last 2 videos has been consistently coming in below what the documentation is saying. So I guess that's a good thing, for people who are using these cards, that they're basically, I think, a little bit more power efficient than you might think according to the documentation. All right, so finally at the next generation, which I guess this would be like the 7th, I think, if this is the 5th, 6th, 7th. So this is the SAS 3816 based chipset based card, which is the 9500-16i. This is the first generation to support PCIe 4.0, although the motherboard that I'm using only supports PCIe 3.0, so we are only running this at PCIe 3.0. It still supports SAS 3 12 gigabits and It still has the tri-mode feature for NVMe, and this is further improvement on the ARM architecture. So this card we know is specified for 3 million IOPS, and so obviously the SSDs that I have will not be able to push the limits on that, but we are seeing at least consistent numbers across the board for all the cards that can handle more than what the SSDs can actually output. We're basically seeing a plateau at the same, roughly around the same number, because it is the limitation of those SSDs that, are the same SSDs. As far as bandwidth, it came in, again, very similar numbers to the other ones, about, 5.8 gigabytes per second or so. And the typical power usage that is specified in documentation for this card is 8.5 watts. And indeed, I think our numbers are very consistent with that. And this is also the same in the previous video when we tested out the 8-port version of this card, which is the 9500-8i. We noticed that the idle power consumption seems relatively lower than the typical. But under load, the number that we're reading is pretty much matches the typical, I believe. So it was 6 watts at idle and 8 watts under load. And again, this generation of cards seems to be the more dynamic in terms of its power consumption, whereas in the previous generations, I think the idle power consumption versus the power consumption under load did not really differ that much. Maybe just by a few percentages, and whereas in the 9500 generation cards, we're seeing things like 6 watts to 8 watts, so that's a 33% difference there. And so these cards definitely can conserve power more when they're not under load, and will consume more power when it's required. I will be following this up with videos where we're going to test the 4-lane cards as well as the 24-lane cards. And then we're going to be testing out the external cards as well for the 8 external lanes and 16 external lanes. And those will be separate videos. So anyway, if you're interested in that, stay tuned to my channel, as those videos will be released in the upcoming weeks. All right, guys, that's it for today's video. If you found this information useful, please give this video a like, and if you are new to this channel and you like this sort of stuff, consider subscribing to the channel. Also, if you want to support my channel, go check out my eBay store. I've got the best selection of pre-flashed IT mode HBA SAS controllers for your ZFS, TrueNAS, or Unraid builds, so go check out the link down in the video description. Thank you very much for watching, and have a great day. Bye-bye.